Welcome to the Robust Design and Optimization session. It's my pleasure to introduce all the authors. We will have 5 papers and the session will last for 1 hour. The first, what I have a pleasure to congratulate to Camilla Wehlin for the Reviewers Award for the paper Multi-Objective Optimization of Hose Assembly Routing for Vehicles. Only this is the Reviewers Award is given to the top 10% of papers based on the reviewers' grades. So only 22 papers have reached that status, and this is from, if you consider that we had more than 400 papers in the mill, this is quite a result. The second paper, obviously presented by David, please take into account that it's in New Zealand, it's really early now. The paper is calculating target thresholds for the margin value method using computational tools. And the third paper will be presented from northern part of Europe, from Finland, robustness improvement using open source code libraries by Josefina Sanchez. The fourth paper will be robust design for Internet of Things, the relevance of mechanical design for robust sensor integration in connected devices. This will be presented by Herle, I see here, yes, Herle Bagh. And then the last but not least, the paper presented by Professor Felician Campean from United Kingdom, Reliability Research Road Mapping Workshop, Implications for Engineering Design. I think this is a paper that will be, in an interesting way, will show, I would say, how we can apply robust design methods in engineering design practice. Robert, please start the presentations.
Welcome to this presentation of multi-objective optimization of hose assembly routing for vehicles. In industry today, the trend is to develop more complex products, combining technologies from diverse disciplines. One such example is modern cars, where many components and systems are integrated in a confined geometrical space. When designing the routing of hoses in the engine compartment of a vehicle, such as air pipes and wires, engineers are often dealing with many conflicting objectives, for example, material costs and production aspects. This leads to many iterations and repetitive work in the development process, demanding a large amount of resources and coordination. Today, we will present a method for hose routing assemblies in vehicles built on design automation and design optimization, which enables automatic generation of a set of optimized hose routing assemblies where multiple objectives are considered. It is intended for decision support and automation of tasks in the conceptual stages of the development process. Now we will give a brief description of the framework of the proposed method. The main parts are CAD, an interface, simulation, and optimization. First, points representing start and end nodes of each hose are set out in the surrounding geometry. An interface is used to import the CAD data for entering routing prerequisites such as cross-section diameters. Then the automated routing is initiated from the interface. The simulation software finds collision-free paths for each hose with respect to the surrounding geometry. The hose assembly is then simulated on gravitation and stress. The routing results are obtained from the simulation and are evaluated as optimization objectives. The routing input is controlled by the optimization algorithm, meaning that it regulates the order in which the hoses are routed and through which points they are drawn. The result of an optimization run is a set of Pareto-optimal hose assembly designs. The multi-objective optimization formulation consists of 4 objectives. These are to minimize the total volume of the hoses in the assembly, to minimize the highest stress of any of the hoses, to maximize the clearance in between hoses and between the hoses and specified critical components. Clearance is necessary to account for vibrations, especially near components with sharp edges or hot surfaces. Designs where collision-free paths for all hoses in the assembly are not found are considered unfeasible. The design variables are the permutation deciding the order in which the hoses are routed, and the placement of so-called via points. Via points are used to control the shape of the hose. Varying the placement of them enables the optimization algorithm to find routing compromises in order to obtain globally optimized assemblies. The framework has been developed for optimization of the placement of either 1 or 2 via points per hose. The via points can be placed within constrained spheres. With 1 via point per hose, the spheres are centered between the 2 nodes of each hose, with the radius as large as the shortest distance between the nodes. With 2 via points per hose, each sphere is centered around each node, with the radius half of the distance between the nodes. The via points are defined by spherical coordinates, which are design variables in the optimization. As verification of the proposed method, the framework has been implemented and tested. The implementation has been done using CATIA, Excel, Industrial Path Solution, and Mode Frontier. An excerpt from the interface created in Excel is shown here to the right. To test this implementation, an industrial case from a car manufacturer has been used, where 3 hoses with 2 different cross-section diameters are routed within the same space. The result from 2 runs using a genetic algorithm shows that the obtained material volume in the Pareto optimal designs presented in this chart are close to the reference solution. The results also show that larger or similar clearances can be obtained, both between hoses and to the critical component. Here to the left, we see an example of a Pareto optimal design obtained from the framework, where 2 via points were used, together with the reference solution to the right. To summarize this, we have presented a method for automation and optimization of routing of multiple hoses in vehicles. A framework has been developed and implemented using an industrial case from a car developer. The framework increases knowledge and provides systematic exploration of design space options in the early stages of the design process. The framework enables evaluation of multiple objectives in the form of conceptual assemblies and provides decision support. It has potential to reduce repetitive work and iterations in the development process. The framework and proposed method is generic and modular and can thus be reused in continuous development cases as well as other applications.
It was perfect in timing and everything. Let's go to the second presentation.
Hello, everyone. Thank you for joining in. My name is Arindam Brahma, and I'm presenting from the University of Auckland in New Zealand. The topic of my presentation is calculating target thresholds for the margin value method using computational tools. I'm working under the supervision of Dr. David Wynn, who is also the co-author of this paper. One of the central concepts used in this presentation is that of margins. So before we begin, I would like to give you a quick introduction on the topic. Margins are quite commonly used by design engineers for various purposes, and consequently, there are quite a few definitions of margins which can be found in literature. Some researchers introduce margins as change absorbers. Some relate margins in terms of adaptability, and some say that they emerge as a byproduct of suboptimization. What's common to all these definitions is that they are basically the difference between the ideal and the actual value of a parameter in a design. This leads into the problem. Margins have both desirable and undesirable effects. Desirable because they can be potential change absorbers and therefore can cater to the uncertainties involved in design. Whereas undesirable because of the obvious overspecification related problems such as unnecessary cost, excess material, etc. So the question therefore is how to create a balance between them. How to create a balance between having insufficient and excess margin, both of which have consequences. We have developed a method called the margin value method, which can be used to identify, localize, and size excess margins, and therefore help decide how to use these margins effectively to optimize a design. The method is based on the idea that decisions are what lead to these excesses in design, and finding out which decisions cause how much margin. The method is intended for an existing design where all the decisions have already been made and all the parameters and their values are known. In the approach, we calculate 4 metrics, results of which can be plotted on a graph. The vertical axis shows how much of the margin can be absorbed, and the horizontal shows how much the margin degrades or deteriorates the performance. The research paper in which we introduced the method, we had worked on a routine design problem of a conveyor belt design. All calculations in that design were based on algebraic relationships and did not have any complex calculations involved. In the paper submitted to the conference, we therefore are demonstrating an additional insight through an example of a flanged coupling, where finite element analysis is required in the calculations and not just simple hand calculations. As the method suggests, we create a design process model, then a margin analysis network, which leads to the calculation of the 4 metrics. In this particular case, we have used a topology optimization algorithm to optimize the geometry, thereby figuring out the margin in that particular component. The resulting graph is shown on the right-hand bottom corner of the screen. There are 3 points where margins were found. Just to give you an idea of how the results of a realistic design would look like, these were the margin analysis network on your left and the margin value plot of the conveyor design on your right. This case had 9 places where margins were found, some of which could be optimized. To conclude, this paper adds insight to the margin value method by showing how it can be applied in situations where necessary threshold values cannot be accurately expressed using algebraic expressions. It suggests how the margin value method could help to identify opportunities to improve design performance using additive manufacture of selected parts. It could perhaps be used in the field of design for additive manufacturing. Obviously, there are quite a few challenges, one of them being that the resultant geometry of such optimizations are usually complex and may not be practical to manufacture. The margin value method also calls for calculations to be repeated, which means finite element analysis must be run multiple times, making the process computationally intensive. And we have so far not considered the errors emanating from the algorithms themselves. In the future, we aim to relax these assumptions. More on these in a recently published research paper, which goes into much detail about the method with a more detailed example of the conveyor belt design. Thank you.
Just perfect. Thank you. Let's go to the third presentation.
Hi, my name is Josefina from Otto University, and together with Professor Kevin Otto and master student Zachris Björkman, we have prepared this presentation to introduce our paper, Robustness Improvement Using Open Source Code Libraries. Why robust design? Complexity is growing in modern systems. High-quality expectancy and tight constraints make product difficult to manufacture, because any small variation in the process can generate a quality issue. Here, an airspace refrigerator system was optimized to achieve a certain capacity with lighter weight. As we optimize a design closer to constraints, we end up with sensitivity designs prone to quality problems. For this, we put together a set of manual and computational tasks to perform robust design using optimization and uncertainty quantification methods. The workflow is divided in 4 main groups of activities. Problem clarification, where we define the model of our system. Then a screen method is applied to screen all the input variables and leave only the ones that contribute the most. Then, to understand the random event performance deviation, uncertainty quantification methods are applied. And finally, the tool change generates factor flows to provide means of understanding the impact of design changes on the response variability. The tool change is built on top of a Jupyter Notebook environment. This environment is self-documenting and consists of descriptive HTML blocks and operative Python code. I would like to show you an example of where we can implement the workflow. At Alta University, students fabricate Stirling engines with different tolerances within them. When the engines were tested, the performance response distribution showed 27% variation, which led to a question to the teaching team. Can the variability in speed be reduced? To answer this, we implement the workflow. The first step in the workflow is to implement a variation mode and effect analysis to conceive list of all potential sources of variation. In our example, 105 variation modes were identified. The next step is that these variation modes are translated into dimension of our engine, such as length, diameter, which will represent inputs of the simulation mode. Some simulations have thousands of inputs, so the next step in the workflow is to implement a fast screen. Here we use Morris method. The result will be the input variables that contribute the most and the ones that don't influence much using a small number of samples. As a result, we get the compression and expansion sweat volume and the compression clearance volume as highest contributors. The input variables on the left-hand corner do not contribute or have a very small contribution. Having identified the largest contributors to the engine power variability, the next step in the workflow is to implement the main experiment. We have chosen design variables of the hot and cold side volumes, which will be easily changed and also impact the power generated. We chose a range of ±20% of the nominal design in order to explore how the design changes impact the variability due to tolerances, but not so large that require changes to the design concept itself. One important part of the workflow is the reference compute unit that will be replicated and run for each of the samples. The reference compute unit has a structure that allows for troubleshooting and user verification, as each design point folder contains a set of folders for each sample mode, and each of these folders are copies of the reference folder. So between the reference folder, we can individually execute the simulation to compute the performance response. The next step in the workflow is to perform uncertainty quantification. Here, the tool change creates UK samples for the simulation using Sobol sampling, and the simulation runs at each point. At each design point, a histogram of the run result is formed, and the mean and variance of the design value is computed. Here we can see that the result of design number 1 has an average power of 1.69 watts and a standard deviation of 0.17 watts. Next, the toolchain generates factor plots to study the effect that the variable values changes have on the power mean and variance. From the factor plots, we can see that the first and last variable can reduce variability, which are the cold and hot side dead volumes. The third variable does nothing, and the second variable can shift the mean power without affecting the variability. The next step in the workflow is to compute the robust solution. To select the optimum design variable values, we solve an optimization formulation using surrogate models of the mean and variance. We use an optimization to generate the Pareto frontier of the variability versus performance. The last step in the workflow is to perform a solution verification. We recompute the uncertainty using the optimum design point, using the same level of input variation. We can see on the histogram of the power response a comparison between nominal and versus optimum values, and the sigma power decreases from 0.18 to 0.14, demonstrating a 23% variation reduction. It is clear that complex systems require robust design, but the implementation of it remains difficult to engage engineers, particularly with complex simulation tools. So we have presented a tool chain that easily implements robust designs, and we only need to set up a simulation in a folder, and then we are ready to perform robust design. Thank you for your time.
This is also nicely prepared recording. Robert, let's go further. Thank you.
Hi, my name is Herle Juul-Nyholm. I'm a PhD student at the Technical University of Denmark. The paper I will present is called Robust Design for IoT, on the relevance of mechanical design for robust sensor integration in connected devices. The motivation behind the paper is that there is an increasing activity in connecting things to the internet. Traditional mechanical products are now enabled for digital monitoring and control through the integration of sensors. But these sensors have to be robust and reliable. If the conversion from physical parameters fails, for example in an electromechanical interface, the digital output will be deficient at best and misleading at worst. Other observations are that the development of sensor systems is often sequential and focused on the electronics. The case of encoders is used to show that mechanical noise factors are important to consider as well. We present an electromechanical trade-off example and illustrate that the sparse literature on variation and trade-off mitigation strategies revealed methodical gaps for robust design of IoT devices. In the literature review, we found that there is a gap in methods for early assessment of interdisciplinary trade-offs. Also, the literature on sensor design focused mostly on accuracy measures, not design heuristics. Carr, on the other hand, he divided accuracy error sources into 5 categories. 4 of these were used as a framework for encoder noise factors. These are static, dynamic, insertion, and environmental noise factors. A contact encoder works as follows. What you can see here is the reader and the scale on top of the circuit board. The input is rotating the reader so that the 2 reader points slide over the scale. The reader arms are pre-tensioned to ensure continuous contact. The setting technology is conductive, which means that different current paths between the reader and the scale creates a code that can be converted to a rotation. In figure 1, the encoder is subject to internal static and dynamic noise factors. The in and output are subject to insertion noise factors, and the whole system is subject to environmental noise factors from the physical context. In the paper, the noise factors are shown in a P-diagram in figure 2 as the uncontrollable noise factors influencing the performance of the system. To answer the first objective of the paper, Table 1 shows the noise factors belonging to different categories, as well as their influences on the mechanical, electrical, and software domains. One example is the scale swash. The swash, or tilting between reader and scale, changes the reader path from circular to oval, which compromises the scale steps. Furthermore, it also leads to variation in the contact pressure between the reader points and the scale, which both influences the frictional torque in the mechanical domain and the resistance in the electrical domain. For the second objective of the paper, this example shows an electromechanical trade-off in the contact encoder. The variation of contact pressure may not only be due to swash, but also to the reader arm thickness perturbation. On the mechanical side, the combination of pre-tensioning force and the rotation creates a frictional torque T-nu, which should be as small as possible because it affects the device system and therefore compromises the measurement. On the electrical side, the pre-tensioning force creates a conductive connection with a resistance RC between the reader point and the scale, and this should be as high as possible to reduce the required power. The trade-off is illustrated in figure 4, where the reader arm thickness is perturbated by 1%, and the torque and the resistance are increasing and decreasing respectively. Looking at the current situation, the mitigation strategies are mostly focusing on single domains. That is, geometrical rules of thumb, moving the average of the current to increase the electrical signal-to-noise ratio, as well as calibration and interpolation in the software. The only example of an integrated interdisciplinary mitigation strategy we found is the gray code. It is superior to the natural binary code, which is sensitive to misalignment of reader points in the scale. All of this leads to an identified gaps that there is a need to generalize or extend this investigation to other sensor types. There is a need to develop integrated mitigation strategies for interdisciplinary design, and a need for early evaluation of sensor system robustness, and also in which contexts this evaluation is most relevant. Thank you for listening.
Thank you very much. And let's go to the next presentation. Felician, we will listen now on you.
And welcome to this talk on the Reliability Research Road Mapping Workshop. I'm Felician Campean, and I'm a professor of reliability engineering at University of Bradford in the UK. I would like to start by acknowledging my co-authors, David Delaux of Valeo, France, Sanjiv Sharma of Airbus, UK, and Jonathan Bridges, formerly of Jaguar Land Rover, now associate of the University of Bradford. The motivation for reliability research stems from the continuous evolution of the business drivers, technology development and innovation, and the product development environment itself, as illustrated by this analysis of the automotive context. Developments in reliability methodology appear to lag developments in business and technology, and this affects the business competitiveness. The Reliability Research Road Mapping Workshop aimed to bring together industry and academia to explore jointly the key reliability challenges, identify the gaps in knowledge and methods, and propose directions for fundamental and applied research activities that will have significance and impact to industry. The workshop had 27 participants, representing 4 countries, the UK, France, Netherlands, and Sweden. From 16 organizations, 3 universities and 13 companies representing the automotive, aerospace, defense, and marine sectors. The workshop was structured on 3 themes: technology development and innovation, exploring reliability challenges stemming from the accelerated adoption of new technologies; right first time through design, focusing on methods needed to better support reliability in product development; and intelligent vehicle health management, exploring ways in which big data, machine learning, and artificial intelligence can be used to leverage enhancements on dependability and resilience of systems throughout their life cycle. The workshop process included a panel discussion led by industrial agenda-setting talks, followed by roundtable discussions and summary presentations from each roundtable. The post-workshop analysis was based on the workshop data, consolidated on themes, further review with a core stakeholder group. The main outcome from the workshop was the research roadmap that captured the main research directions along the axis of technology readiness levels and timeline. The summary of the thematic discussions are detailed in the paper, with the key research directions captured on the research roadmap as shown here for theme 1. While there is still a need for accelerated test methods and whole system reliability modeling aligned with the global real-world usages, more fundamental research is needed for modeling the aging of autonomous systems and software aging testing and monitoring. The main outcomes from Theme 2 discussions include short-term actions for reliability modeling skills and model-based systems engineering for reliability early in product development, while lower TRL research should focus on artificial intelligence for automatic model-based systems engineering and agile verification test plans. Finally, Theme 3 outcomes emphasize the need for action on shared reliability data across industries, online dynamic reliability model for diagnostics and prognostics of complex systems, and digital twins for reliability, and most interesting, the minimal data set for reliability guarantee for a given mission. In conclusion, the workshop has achieved its purpose in that it has delivered a roadmap for reliability research focused on the industry needs, and it has also created an engaged community with a clear shared agenda. Thank you for listening, and please get in touch if you share our passion for reliability.
Thank you very much, Felician, also for preparing such a presentation. This was quite nice, but I'm really happy that we have done this in time as planned, so we have half an hour for discussion. You have been quite sparse in writing, and I will start. It's obvious that Jonathan has also been triggered by his engineering background and practical experience with the questions for the first paper for Camille, and therefore what I would also like to ask about this paper is I think Jonathan has pointed out key points which are quite close to my view on the paper. I would also ask, I will also add to Jonathan's questions. It's obvious that this is done in a quite late phase of detailed design. So the question is how the accessibility has been taken into account in this optimization, because the via points and volume space does not guarantee accessibility, if I'm by my view. Can you discuss on these questions, please?
Yes, first of all, thank you for the good questions. I will try to answer them all. So first, for the via points, in this setup, we use them mostly as preforming, so that when these hoses would be produced, they would be formed, representing the assembly that has been optimized. But it could also be used as clipping points or fixing zones, as Johan mentioned. Dorian, I don't remember now which was your addition to this question. Was it for the first one or?
Sorry?
I don't know if you had an addition to this question that maybe I missed now in my answer.
Have anything to add or to reply on this?
Otherwise, I will just go to the next question, I guess, which was addressed about the dynamic clearance, which is obviously needed in vehicle applications. For this implementation of the framework, we have disregarded dynamic simulations, which can be done in the simulation software that we're using. We can see dynamic clearance as an input, since we input a minimum clearance that each host needs to have to the surrounding and to other components, as well as using this objective to try to maximize the clearance, which we see as accounting for dynamic simulations or dynamic clearance, which could be revealed in simulations. And the reason for this is actually the same as the next question, which was about the production variability and ease of assembly and such. And these are all simulations that could be done in the simulation software that we're using. Although we have not considered these for this implementation, be able to have a computational efficient optimization evaluation. So since we want to evaluate each solution many times, or different solutions many times, this has not been considered, but it's obviously considered in a larger sense. So this is definitely something that we will address in coming steps of this research. So I don't know if that answered your questions.
The third question, okay, here it is. Can you, about production variability and capability, the essence efficiency of assembly considered?
Yeah, as I mentioned, the same answer, that it's not been considered in these implementations because of the limits of computational power, that we need to have efficient models so that we can run the evaluations needed in the optimization algorithm.
Okay, thank you. Let's go by the order of the questions. Herle has asked about the research road mapping workshop, and we have also two questions in a row, one from Herle and one from Josefina. Felician, can you address these questions?
Yes, can you hear me?
Yes.
Oh, thank you. Because
a little bit silent.
Sorry, I'm gonna try to keep it closer. So I could hear you very well, but I've struggled earlier on to make myself heard. So first of all, thank you. So first of all, the first question is the association between the research teams and the sub-direction. So that was the process of consolidations of the ideas gathered from the workshop, and we've taken recordings as well as having the post-it notes and so on. So it was quite a long process where we've been and grouped this, and then the association with the technology readiness levels and time was something that we've done with the core stakeholder groups, and by that I mean the co-authors of the paper as a group. So we had quite a lot of interesting discussion in relation to what's the association between technology readiness levels and time. Okay, because when we talk about hardware, about physical systems, the technology readiness levels you talk about, possibly 4 to 6, 4 to 10 years. Whereas when you talk about software interventions, that's much faster pace. So it's actually interesting to look at the facts. So if you look at it from the point of view of the academic research, the association between TRL level and time is perhaps best to be taken separately. So ideally, I would have preferred to have two graphs, but then you limit it for space. The numbers associate with the technology readiness level. So TRL 1 to 3, that's usually fundamental research, so academic research. 4 to 6 is translational research, proof of concept, and then 7 to 9 is implementation in industry. The question from Josefina is actually very interesting. Is design with obsolescence. That's really important, because so we have reflected that in the workshop, both from the point of view of obviously software is now a big thing where you have almost a continuous product development. So if you look at the automotive industry, you launch hardware, but we started to see quite a lot of software-defined features, and of course you update software a lot more often than hardware, and therefore you need to plan the obsolescence. That trend is only going to become worse as if we're going on the path of servitization of the transport industry in particular. What we're going to see is increasingly hardware for propulsion system, for example, being designed for a far longer period of time. But the specific answer to the question is it's an interesting question whether I have seen trends in companies focusing on obsolescence management. I'm not sure. I can't answer affirmative there. So it was a very interesting discussion at the workshop. I don't know, one of my co-authors who has a background in industry, I don't know whether Jonathan, whether you would like to comment on this, maybe via the chat, if the microphone doesn't work. So
can you go? Jonathan.
So maybe if you move on, Dorian, and Jonathan might answer by.
Okay.
So I know this is an area that he focused a lot while he worked in industry, so that's why I thought it's useful for him.
Yes,
to comment.
I know. Here he is. Okay.
Yeah.
Okay, Jonathan, let's go.
Right. Okay. Thanks. Yeah. Planning for obsolescence is a somewhat undeveloped area in my experience, except for large hardware assemblies. So there's significant activity in remanufacturing, reprocessing of engines, gearboxes, and so on. But as Felician rightly says, much more customer-oriented feature is wholly or partially software-driven now, and in my experience, the automotive industry anyway is still grappling with a very noisy and mixed usage environment, many different conditions of software releases, even within a single series production. And we see developments of software over the air, updates, and so on. But that brings challenges too. I think it's a trend that's yet to start in terms of much better planning for obsolescence. Speaking on behalf of automotive anyway, and I think that well, probably European manufacturers are at the forefront of pursuing that right now. Hopefully that's helpful.
Thank you. Shall we move to the paper or to the presentation made by Josefina about open source code libraries in considering robust design? The question would be, first we have from Herle, we have an interesting question about particular figures. So I would like to start discussion on that point, and then we'll see how we will go proceed. Josephine, can you address the question?
Yes, can you hear me? Can you hear me?
Okay, go. We're hearing you. We hear you.
Yes, so yeah, you understood correctly. It is hard to change the standard deviation, so we want to minimize the standard deviation using the variables that, for example, the hot side bed volume. And later we can use the cold side sweat volume to shift the power mean wherever we want to set it. So, and we can do this in the optimization formulation that we presented. So we are basically trying to use the design variables that can minimize the standard deviation.
Okay, thank you. What I have a question about what I'm considering really is you're using open source library, your open source code. And yes, this is no question, this is useful, and people might start using the tools if they are available. No question about that. And this is quite obvious. But what I'm missing is how you really have contributed to the body of knowledge of robust design area. What is really your contribution? What is really new? Or it is just a question of implementation of existing knowledge into the code?
Well, yeah, as you mentioned, what we are trying to aim is to make this open source code more available for people working in robust design. So sometimes it's very difficult when you are just starting in this in robust design to implement it. So we want to make it more available and easy. That's why, as I mentioned in the presentation, the idea of this workflow is to make a reference folder basically with all the inputs of your designs and creating the design of experiments, and then the workflow and the toolchain will do basically everything. So it will basically give you an easy introduction into how to apply robust design methods.
Okay, thank you. Any other questions for Josephine?
One in the chat, actually.
Let's go. I don't see any. Which one? I haven't seen.
What kind of simulation models are compatible with the tool change? Do you mean, so we have the way of generating the samples, so we can use Latin hypercube or quasi Monte Carlo simulation, and but for like training, yeah, that is for creating the surrogate model. So basically, whatever is available in scikit-learn, it can be used in the toolchain for generating the samples. And then we also use a simulation model in the example that I showed, which is to calculate the performance of in this case, of the engine. So this is more related to whatever you are trying to study. So you need to have some sort of analyzing performance response of your product.
Yeah, I was more thinking if it's okay that I ask the question this way. If it's only analytical models that you can use for, so you input with the CSV file, or if you can set up like an FEA or something like that.
Sorry, I couldn't hear the last part.
Sorry, if you could do like a numerical simulation, or if it's only analytical models that you could use.
Actually, we'll read the answer of Professor Kevin. So yeah, any simulation that you can write in a standalone folder. So it needs to read a column of inputs values from the CSV and then writes the outputs to a CSV file. So it could be ANSYS, like any element analysis. In this case, we are using a MATLAB model that reads the inputs from the CSV file and then runs the simulation in MATLAB. But it could be also used in ANSYS, like reading the inputs from some folder and then running the simulation in that.
Okay, thank you. I see that through chat, Kevin and Felician are getting warm up for the discussion. Let's go also, when we are on the robust design theme, I have seen one question about robust design, which goes to the, of course, I have lost it now. Yeah, there was a question for the paper about Internet of Things. Okay. And yes, I cannot find it now. So someone has asked about for Herle. There was a question. Herle, have you seen this question for you?
No, I haven't seen any questions for me.
Okay, then we will find the question for you. I have it somewhere. This will be quite, I believe, quite easy way. So the first question would be how we, just a second, is if we are using your method beyond the particular sensor implementation, how you can generalize it for other purposes or other applications?
Well, what I'm presenting in the paper is not a method. It's not a finished method. It's just to try and show that mechanical design is important for sensor design. But the way it could be extended is to look at other sensors and see what kinds of trade-offs are implicit in the working principles, and also looking at how different noise factors are influencing different domains, like what I'm showing with this example in the paper.
Okay. Are there any questions for Herle now from the participants? Okay. One point back to the Felician. Felician, you had, okay, there's no doubt the workshop was useful and you have met the objectives of the workshop. What I'm a little bit concerned, and there was a lot of discussion about your paper. Is this a research paper or is it just a report from a workshop? And then we decided to include it into the program because we thought this paper can initiate a discussion that will be interesting, and no question about it, the reliability is important part of, I would say, design research. What I would say, I think not only I'm not the only one, but if you really try to sketch a research roadmap, how could you include, or should you include more people working with the reliability or treating reliability than just a few companies or on a one-day workshop?
So yeah, well, thank you both for the comment. I think the reflection is quite fair. So the purpose of this paper was actually to communicate the outcomes from that workshop, and I believe we had similar papers in relation to the design product development 2040 and so on. So I think these events are actually quite important. I think looking forward, there was a point about getting the discussion going around reliability, and we have started with this workshop, and as you say, we achieved the objective. We are planning a follow-up workshop in June, but that got obviously delayed to COVID. So the follow-up workshop was very much driven by the industrial partners, which was a desire to actually follow up what we've identified as key trends with action plan. I think from the point of view of opening it up to the broader community, both industry and academia, I'm taking here the view that from my one of the things that we've intended from the beginning is to actually identify what are the key challenges in industry, such that we focus from the academic point of view on doing research that will have impact. So will really help what's going on in industry. Without doubt, I think there is an opportunity to broaden this discussion, make a much larger engagement, and I would be delighted if we can do that through the Design Society. I think what this workshop proved is that there is a need, and those needs are very much both short term and also long term. And I think one of the reasons for me, and it's really the way I reflect how different research groups can engage with this. So, for example, there's quite a lot of work on robustness, which really has an implication on the reliability behavior of systems, and that's really important. But if you look at what's very topical these days, for example, autonomous driving, what's now widely recognized is that the trade-off between safety and availability is what's actually blocking progress, right? You can develop a lot more procedure, but if you try to ensure safety, what you very shortly realize is that, well, you cannot achieve safety without having availability too much. And the problem is that we are very far behind in terms of providing the models that would underpin availability in an interdisciplinary environment that combines physical systems with software. Sorry for going on a tangent there, but Dorian, answering the question, I think to me the key point to answering your question is yes. Well, can we do that through the Design Society?
Oh, I believe yes, but I'm not at the moment. I'm not one that can talk in behalf of Design Society. But from experience, absolutely yes. We can chat this in the evening on a social gathering, and we can include team and and also other members. So please gather today after the conference, after the sessions, and gather time. David, I hope you are listening still with us and you are still awake. I realize that it's really very early in New Zealand. So your paper is no doubtly interesting, but what I would like to hear a little bit more about generalization, how this method can be used beyond this one example.
Yes, of course. So thank you for the good question. Essentially, this method is or has been developed to be used in a context where an existing design is to be incrementally improved. So perhaps the designer is committed to a particular design to at least some degree, and they want to be able to pinpoint areas where it can be improved, especially from the point of view of design margin. So essentially, we're looking at identifying aspects where the beneficial effects of margin in terms of absorbing future changes and uncertainties are perhaps outweighed by the detrimental effects in terms of over-design, which could result in increased cost or weight, for example. So we've applied it to a few cases so far. The research is in, I'd say, somewhat early stages. So as well as the clutch example in this paper, there's a more detailed example in a research and engineering design paper that was recently published, which applies it to a conveyor design case. And we've also had a look at some winch design cases. One of the things which we're interested in trying to apply it to is potentially looking at light weighting of existing design, potentially by application of topology optimization and additive manufacture. So we think it could help to identify particular situations within a design that has multiple parts and multiple load cases where there are greatest opportunities for improvement. So I hope that answers the question to some degree.
Yeah, you have, of course. We are almost close to the time when the session should end. So I would give an opportunity for the last question from the audience. You can ask a question to chat or just go directly live. Okay, I'm not seeing any reaction or hand raised.
I have one for Camilla. Yeah, so can it be easily implemented using a different CAD software other than Campean?
Yeah, I don't see why not. In the right bridging between the softwares, like the interface and being able to fetch the coordinates. That's basically from the CAD software. So yeah.
Okay. Is this the answer you have been expecting?
Yes.
Josephine? Yeah.
Yeah, and I have one.
Okay.
More. Okay.
Go.
Okay.
Go.
So also, Camilla, I was reading on your paper that people work in the area of computational methods to quantify the ergonomic aspects of human assembly. So do you know if there is already any software that is taking into account this ergonomic analysis in optimizing assembly solutions?
Sorry, I didn't really get the question, but it was about the ergonomic aspect.
Ergonomic, yeah.
Yeah, this is also, I guess, the same, or it depends on your question, if we have considered it or something that we plan to consider, or what was the question?
Yes, like if you are planning to, if you are considering and if you know any software that is already taking into account ergonomic aspects in finding optimization solutions for assembly.
Yeah, obviously not implemented at this stage, but also a very good point that needs consideration. So when it comes to assembly, it's both the ergonomic aspects and also if the components can be assembled, like can fit, so to say. So yeah, good question, and also part of future development of this tool.
Okay, thank you very much. It is 2 p.m. and we should close the session. What I would like to invite you to, after a 15 minutes break, you should provide a drink for yourself. The conference organizer this year was lazy and didn't want to order individual drinks for each participant for some reason, and then join the first keynote. I think it will be an interesting keynote. Of course, there will be sessions after this one, and then we will have an interesting social game called Gather Town, and we will try to gather in one environment that looks like, I would say, it's, if you have been starting the first game, Snake or something on Nokia, this is something like that. So let's go there after the session ends. Thank you very much. I found this session, it was productive. And thank you to all the authors and presenters and participants. And one moment, now we have 15 participants, but at one moment I saw 19, which is quite a nice number for such a small session and such a small group. Thank you very much and see you later on. Bye-bye.
Thank you.
Thank you.
Thank you,
Goodbye.
everyone. Bye.
Bye.
Thank you. Bye.